What's up, guys? Looking at isotopes this time. Stay tuned at the end for the answers to the atomic structure questions. We'll start here with a great example of an isotope. We've got 3 isotopes of hydrogen. And hopefully you can see what the big difference is. In hydrogen 1, we have no neutrons. In hydrogen 2, 1 neutron. In hydrogen 3, we've got 3 neutrons. It's the relative atomic mass that changes, the mass number that changes. The proton number will stay the same. So if we look at our periodic table, we've got hydrogen, a proton number of 1, and a relative atomic mass of 1 as well. But we do have these 2 isotopes of it. And that sort of helps us with this definition. So an isotope has different version of the same atom different number of neutrons and same number of protons. If we had a different number of protons, it would be a different atom, pure and simple. So this is a perfect example of that. And this isotope thing is what explains the numbers that we find on our A-level version of the periodic table. 6.9, chlorine 35.5, copper 63.5. An individual copper atom is not going to have a relative atomic mass of 63.5. What's happened here is that we've taken a big sample of copper and we've measured their average mass. So when we're talking about relative atomic mass, we're talking about the average mass compared to 1/12 of carbon 12. Right? And so we can really dig into chlorine as an example here. Because even on your GCSE periodic tables, you would have seen that chlorine has a relative atomic mass of 35.5. And we can dive into why that is. Because often we have these calculations. Next session, we'll look at mass spectrometry. And this sort of thing is going to be produced, whereby we can see the abundance of a substance and its given mass. But let's say this for now. We have our sample of chlorine. 75% of those chlorines have a relative atomic mass of 35. 25% have a relative atomic mass of 37. So we plug that into an equation. And all we're going to do is we're going to multiply our mass by our percentage and add that to our next one. So we've got 37 times 25 all over 100. And there, if we put that into our calculator, we get to 35.5. And this is the case, right? So again, 75% of our 75% of our chlorine is chlorine 35. 25% of our chlorine is chlorine 37. We get to this relative atomic mass, again, compared to 1/12 of carbon 12. Look, here we've got an example for you guys to give a go. We've got 19.9% is boron 10 81.1% is boron 11. Give that a go. Answers to come at the end of next video. For now, let's go back to last time's questions. So here we've got our lithium. Let's look at our periodic table. Lithium is here. We have a proton number of 3. No charge, so we know we've also got 3 electrons. And our 7 minus our 3 gets us to 4 neutrons. Lithium again, so it must have 3 protons, but we have a charge here. Electrons are negatively charged, so it must have lost an electron, so we only have 2 electrons. We still have 4 neutrons. Now onto oxygen. We've got oxygen here. We've got a proton number of 8. So we've got 8 protons, 8 electrons because we've got no charge. 16 minus 8 gets us to 8 neutrons. Here again, we've got the same number of protons. It would be a different atom otherwise. We've got a 2 minus charge, so 2 electrons have been gained. And we have 8 neutrons as before. Here we've got an isotope of oxygen with a relative atomic mass of 17. Our proton number will be the same, 8. We've got an atom, no charge, and so 8 electrons. And then our 17 minus 8 gets us to 9. See you next time.